All right, electron configurations are useful, but we have another way to represent the electron configurations, and these are what are known as orbital diagrams. These will be a little bit more detailed and give us more information about the electrons. But we'll just say another way to represent electron configurations. So again, we're going to use our handy dandy periodic table. As long as we've got one of these, our job should be relatively easy. Let's do helium first. So helium is over here. If you think about what the electron configuration for helium is, it would just be 1s2. So what we're going to do in our orbital diagrams is just represent that in terms of a picture. So sometimes you'll see the orbitals represented as squares. Other times they'll just be lines. So this square is going to represent our 1s orbital, and it's filled with 2 electrons. So then we're going to draw our 2 electrons. Remember, one needs to point up, one needs to point down to correspond to that m sub s of plus and minus 1/2. So this right here would be the orbital diagram for helium. Let's do something a little bit more complicated. Let's do nitrogen, which is right over here. If we think about nitrogen, again, we're going to read the periodic table like a book, left to right, line by line. First, we have our 1s orbital. That's filled with 2 electrons, one up, one down. After that, we have our 2s orbital. That's filled with 2 electrons as well, one up, one down. And then after that, we've got our 2p orbitals. Remember that there are 3 2p orbitals. So we're going to write 2p, and that one has 3 different orbitals. Now, when we fill electrons in the same kind of type of orbital where n and l are the same, right? So for like these 3 2p orbitals, they're all the exact same energy level. We call that being degenerate. So for degenerate orbitals, right, they're the exact same energy level. What we have to do is we have to put 1 electron in each before doubling up. Right, they're each going to want to kind of fill their own house before they start doubling up. And that makes sense because electrons have the same charge and like charges repel, so they won't really like each other. And then the other rule is when we're filling these up, they all must face in the same direction. Oops. So for example, nitrogen has 3 electrons here. So we're going to have one spinning up in this orbital. And by convention, you have them spin up first before you have them spin down. But if you want to draw a spin down first, that's fine too. Now, our second electron, we're not allowed to put in the same orbital. We have to put it in another degenerate orbital, and it has to be facing the same direction as the original electron. And then same thing for that third one. So there's our nitrogen. It only has 3 electrons, so they're each going to kind of get their own house, and they're going to each be oriented in the same direction. Let's do one more, fluorine. Fluorine also has its 1s orbital filled. It has its 2s orbital filled, and now it's 2p. Remember that there are 3 of them, and now we have 1, 2, 3, 4, 5 electrons there. So I'm going to put 1 spin up in this one. Second one goes in a different degenerate orbital. Third one goes in the other degenerate orbital, all spinning the same direction. So that's 3. We have to fill 2 more. We don't have any orbitals to put them in empty spaces, so now we have to start doubling up, and when we start doubling up, we put them in the opposite direction. So there's 4, and there's 5, and there's your orbital diagram for fluorine. If you want to play around with a really cool website, ptable.com is very cool with this. So I just type in periodictable.com. Internet will take you right here. And then what you can do is you can click this electrons feature. Once you click this electron feature, it'll be a little bit different. You can see right here, it's got our electron configurations, right? It's talking about the blocks. You have your N values, and then you've got a little up arrow. So the reason that only has one up arrow is because my cursor is over hydrogen. When I move my cursor over to helium, or when I click on helium, we can see that we have it filled. And then in the bottom left, you have a picture of the kind of orbital that you have, right? So it's an S orbital, so it's sphere. Then we start with lithium. Right now we fill in our electron. If you take a look at the bottom left, our orbitals now have kind of two, or it has one node, but you can kind of think about it as like two shells. Then beryllium, right, we're still filling that same orbital. Then with boron, now we start filling a p orbital. If you look at the bottom left, it looks like a dumbbell, and we start filling our p orbital. Carbon now has 2 electrons in the p orbital. Note that they're each in a different one, in a different orientation. Nitrogen now has 3. Oxygen, now we start doubling up, so on and so forth. It also gives you a good look at the orbitals. So there's our 3s orbital. You can tell that you have 2 nodes there. It's kind of hard to tell. Let's see if we can find a better one. Oh, that silicon one was good. You can see that silicon, right, now that we're in the 3p orbital, it actually has 1 node. So you can tell they kind of just get bigger and bigger and bigger, right? If we move down the same column, you see the orbitals get bigger and bigger, but all they're doing is just kind of adding extra nodes to them. There's our d orbitals, right? So that's that kind of funky looking one. There's the kind of 4-leaf clover, if you will. And then we kind of move on, continuing on, so on and so forth. Let's find that 4-leaf clover one. And then when we move down, we can see that we just kind of get more and more of these kinds of layers. And there's our f orbitals. Right, you can see they look pretty intense. We won't have to draw any of these. And again, all the electron configurations are right there. Or I mean, orbital diagrams really. And then our electron configurations are right here. So play around with this website. You know, just pick an element, try to draw out either its electron configuration or orbital diagram, and then check your work.